So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir and today we are going to learn the important topic, that is recursion. Now what actually recursion means? By definition, it means a function calling itself to solve a problem. This is a syntax, that is a function calling itself. Now let's see with the example. Here we want to find the factorial of a number, that is 6. Now, how actually recursion help us to find any problem? Let's say here to find the factorial. Now, when we call f of 6, it will do 6 into f of 5. This is nothing but 6 minus 1. When f of 5 is called, this will do 5 into f of 4. Here 4 is nothing but 5 minus 1. Similarly, when f of 4 is called, this will do 4 into f of 3. F of 3 will do 3 into f of 2. F of 2 will do 2 into f of 1. When f of 1 is called, it will simply return 1, because we know that 1 factorial is nothing but 1 only. So 2 into 1 will be 2. So factorial of 2 is 2. Now 3 into 2 is 6. So value of f of 3 is 6. Now 4 into 6 is 24. So value of f of 4 is 24. Why f of 4 is 24? Because f of 4 is doing this stuff, and till now we got 24 as an answer. So f of 4 is 24. Similarly, 5 into 24 is 120. So f of 5 is 120. Now 6 into 120 is 720. So f of 6 is 720. So in this way we find the factorial of a number 6. Now let's see how, with the help of stack, we find a factorial of a number using a recursive code. Let's take n as 6. Now initially f of 6 is being called, that will do 6 into f of 5. Now f of 5 will be get called, that will do 5 into f of 4. Now f of 4 will be called, that will do 4 into f of 3. So in this way this will be get done. Now when n is 1, let me put the value of n. When n is 1, this statement will get executed and it will return 1. So f of 1 will return 1. So value of f of 1 is 1. So 2 into 1 is 2. So f of 2 will return 2. This will return 2. 3 into 2, that is 6. So f of 3 will return 6. Now 4 into 6 will be 24. So f of 4 will return 24. Now 5 into 24 is 120. So f of 5 will return 120. Now 6 into 120 is 720. So we get f of 6 as 720. So this will be written finally. Now let's understand something about function when it comes to recursion. Here the first property is every function has its own value. Like f of 6 is different function, f of 5 is different function, but values of n are not common, they are different. Here 6, here 5, here 4. Therefore we can see we are saying that every function has its own value. The second point is every function is of same size. The size of a function f of 6 is same as size of a function f of 5. The third point is the one who gets called will be first to pop. Since we are using a stack here and a stack has a property of last in first out, the function who gets called last will be the first to pop. We know that this recursive function recursive program uses a stack data structure. The fourth point is every recursive function should have a termination point, at least one termination point. Otherwise stack overflow will occur. This means that here this is the termination point, also known as a base case. If we don't have a base case, then this function will execute this statement, and due to this it will call f of n infinite number of times. Due to this, stack overflow will occur. Now the last point is that will be the real definition of recursion. It means solving a bigger problem by dividing into a smaller problem. That means to solve a big problem we will call smaller problem. We will divide into a smaller problem, and the result of this smaller problem is transferred, or we can say is passed to a parent problem, and in this way we solve the big problem. Since we are dividing the problems, this recursion comes under a divide and conquer strategy. Now let's understand the final point. Now this piece of code is also used to find the factorial of a number, but this is not a recursive code, it is a iterative code, but this use one unit of stack. And if we take a look at this recursive code, it is actually taking 6 units of stack. So by space comparison, iterative code is much better, but when it comes to time complexity, both are same asymptotically. So in next lecture we will going to learn how to find the recurrence relation from the recursive code. Thank you.